Hello everyone. So now we have a question which says that out of these four complexes A, B, C, D, which of these complexes will not show an ideal octahedral geometry? Okay, so we have A, nickel complex, hexa aqua nickel plus 2, and then B we have hexa aqua manganese plus 2. Then C, we have hexa aqua chromium in the +3 oxidation state, and D, we have hexa aqua titanium in the +3 oxidation state. So we have to identify that out of these four complexes, which one will not be a regular octahedron. Okay, so this question is based on Jahn-Teller distortion, which says that because of the unsymmetrical distribution of d electrons in T2G and EG orbitals, the regular geometry of the complex is distorted from octahedron to tetragonal or square planar. So we will keep that in mind and then we will solve this question. And for that, what we have to do, we have to check out the d electron distribution in the central metal ion of these complexes. Okay, so moving to the first option, nickel H2O whole 6 2 plus. So one thing I just want to mention here, that in all the four options, as you can see, the ligands are H2O, aqua ligands, and aqua ligands, we know that these are weak field ligands. So in all these cases, the d electrons will not be paired, okay, in the first case. So all of these are high spin complexes, weak field complexes. Okay, now so in the first part we have nickel in the +2 oxidation state. So nickel in the ground state will have this electronic configuration, valence electronic configuration as 3d8 4s2, and in the +2 oxidation state it becomes 3d8. Okay, now how to arrange these d8 electrons? So T2G will occupy without pairing like this. Okay, so 5 electrons, and then the pairing will occur, so 6 7 and 8. So we can see here that the T2G orbital is occupied symmetrically with 6 electrons. Okay, symmetrical filling of T2G orbitals, and EG orbital also is symmetrically filled, so 2 electrons in 2 orbitals. So both are symmetrically filled in this nickel complex. T2G is also symmetrically filled, EG is also symmetrically filled. So there is no probability of Jahn-Teller distortion here. Okay, and that is why the regular geometry will not be distorted. So it will be, this nickel complex will be a regular octahedron. And then we move on to the second B option. Okay, so B has a manganese complex. So manganese in the ground state will have 3d5 4s2 valence electronic configuration, and then in the +2 oxidation state it has 3d5 electrons. Okay, now we have to arrange these electrons in the T2G and EG orbitals. So how these will be arranged? Without pairing, so 1 electron in each orbital, so 3 in T2G and 2 in EG. So here also you can see this T2G is symmetrically filled, okay, symmetrically filled T2G, and EG is also symmetrically filled here because T2G contains 3 orbitals, 3 electrons. EG contains 2 orbitals, 2 electrons. So symmetrical filling in both these cases. So here also in this manganese complex also no Jahn-Teller distortion. So manganese complex remains regular octahedral geometry. So now for the chromium complex. The chromium complex in the ground state has 3d5 4s1 valence electronic configuration. And in the +3 oxidation state, it will show 3d3 4s0. So only 3 electrons in the d orbital. And these 3 electrons are accommodated in the T2G orbital like this. And now we can see that T2G orbitals are also symmetrically filled. So 3 orbitals, 3 electrons. So we have symmetrical filling of T2G orbitals. And because of this symmetrical filling of T2G orbitals, we have no Jahn-Teller distortion for this chromium complex. So this chromium complex will also show perfect octahedral geometry. Now moving on to the titanium complex. Titanium complex in the ground state, it will have 3d24s2 valence electronic configuration, and in the plus 3 oxidation state, it will show 3d14s0. So this one and only electron gets accommodated in the T2G orbital. And as we can see, there are three T2G orbitals containing one electron. That means this filling of one electron in the T2G orbital is an unsymmetrical filling. That is an uneven filling. Okay. And this uneven filling of this T2G orbital shows Jahn-Teller distortion. Okay. So this titanium complex shows Jahn-Teller distortion. Even if slight, because the T2G orbitals are unsymmetrically filled, so there will be slight Jahn-Teller distortion, not a stronger one. But due to this slight Jahn-Teller distortion, also the perfect octahedral geometry will be disturbed or distorted. So amongst these four complexes, the titanium complex will show slight Jahn-Teller distortion, because of which the ideal octahedral geometry will be distorted. So option D, D only. Neither A, D or C, D, but only D. So I hope this explanation was clear to you. And if these videos are helpful to you, please like, share and subscribe. And please let me know in the comment section that what you want to learn next in chemistry. Thank you so much.